For weeks, one of the strangest visitors our solar system has ever recorded simply vanished. Every telescope on Earth lost it completely, swallowed by the glare of the sun, and nobody could say for certain what it was doing out there in the dark, or whether it would even come back the same way it left. When it finally reappeared, the readings coming back left scientists at NASA genuinely stunned. This is the story of 3I Atlas, the third confirmed interstellar object ever detected passing through our solar system, and the strange, tense stretch of time when it effectively disappeared from view, only to return with data nobody fully expected. Let's start with why this object matters so much in the first place. On July 1st, 2025, a telescope belonging to the ATLAS survey, a NASA-funded network designed primarily to spot dangerous asteroids, picked up something moving unusually fast across the sky from a station in Chile. At first, it looked like it might just be another routine asteroid detection. But once astronomers calculated its trajectory, everything changed. This object was moving on a hyperbolic path, meaning it was not gravitationally bound to our sun at all. It hadn't formed here. It was passing through from somewhere else entirely, another star system, flung out into the emptiness between stars countless years ago. Interestingly, once astronomers went back and combed through older archived images from before the official discovery date, they found faint traces of the object dating back weeks earlier, sitting quietly unnoticed in prior survey data. That kind of retroactive detective work is fairly common in astronomy, and it helped researchers refine the object's exact trajectory and speed far more precisely than the initial discovery data alone would have allowed. That made it only the third confirmed interstellar object humanity has ever detected, following Oumuamua in 2017 and Borisov in 2019. But 3I Atlas immediately stood apart from both of its predecessors. It turned out to be significantly larger, significantly brighter, and remarkably, evidence suggested it might be far older than our own solar system itself, potentially a frozen relic that formed around a star that existed long before our sun ever ignited. To understand just how rare this kind of discovery really is, consider that humanity has now spotted 3 confirmed interstellar objects total, ever, across the entire history of organized astronomy. The first, Oumuamua, sparked enormous public fascination back in 2017, partly because of its strange, elongated shape and the fact that it showed no visible cometary activity at all, no glowing tail, no obvious gas or dust being released, something astronomers still debate the explanation for to this day. Borisov, spotted 2 years later, behaved much more like a traditional comet, giving researchers their first real close-up look at cometary activity from an object that clearly didn't originate in our solar system. 3I Atlas represents the third data point in that still very short list, and given how large and active it turned out to be, it has already provided astronomers with more usable scientific data than both of its predecessors combined. As astronomers around the world turned every available instrument toward this ancient visitor, the discoveries started piling up fast. NASA's Swift Observatory detected water being released from the comet at an astonishing rate, roughly 40 kilograms every single second, and it was doing this while still remarkably far from the sun, much farther out than typical comets usually become active. Later, instruments aboard NASA's Europa Clipper spacecraft managed to capture rare ultraviolet observations of the object, catching a glimpse Earth-based telescopes simply couldn't achieve on their own because the sun was blocking their view at that particular moment. Then, in October 2025, 3I Atlas reached perihelion, its closest approach to the sun. And this is exactly where things got complicated. As the comet swung closest to our star, something happened that had astronomers holding their breath. From Earth's perspective, 3I Atlas effectively disappeared. Its position in the sky placed it directly behind the glare of the sun, making it completely unobservable using ground-based telescopes for an extended stretch of time. For weeks, humanity's most direct window into this ancient interstellar visitor simply went dark. History gave researchers plenty of reason to worry. Plenty of comets throughout recorded astronomical history have approached the sun only to break apart under the combined stress of intense heat and gravitational tidal forces, sometimes disintegrating into scattered debris within just days or hours. Because 3I Atlas represented such a rare, irreplaceable opportunity to study genuine interstellar material up close, the possibility of losing it entirely during this blackout period weighed heavily on the researchers who had spent months building their observation plans around this single object. There would be no second chance, no follow-up mission, no way to send another spacecraft chasing after it if it broke apart completely out of view. During that blackout period, the only real eyes humanity had on the situation came from spacecraft positioned elsewhere in the solar system, far from Earth's blocked vantage point. Mars orbiters operated by the European Space Agency managed to catch glimpses of the comet as it passed relatively close to the red planet, capturing images of its glowing coma from an angle no Earth-based telescope could match. It was, quite literally, humanity's other eyes in the solar system stepping in while our primary view remained completely cut off. If you're finding this story as gripping as I am, go ahead and hit that like button. It genuinely helps this channel keep bringing you deep dives exactly like this one. Then, as 3i AUS Atlas finally began moving away from the Sun in December 2025, telescopes on Earth regained their view, and the data that came flooding back genuinely surprised researchers. First, the comet had survived. It had not disintegrated during its closest solar approach, which was itself a relief, but the details of exactly how it looked afterward turned out to be far more interesting than anyone expected. Using the Hubble Space Telescope in late 2025 and early 2026, scientists were finally able to separate the faint glow of the comet's solid core from the much brighter surrounding coma, the cloud of gas and dust released as ice sublimates off its surface. That analysis revealed the solid nucleus itself, measured roughly 2.5 kilometers across, making 3i Atlas significantly larger and more massive than Borisov, the previous interstellar comet discovered back in 2019. Then came an even bigger surprise. In December 2025, the James Webb Space Telescope detected methane inside the comet's coma. Methane is what scientists call a hypervolatile ice, meaning it only remains frozen at extremely low temperatures. Detecting it clearly meant this comet had been sitting somewhere unbelievably cold for an unbelievably long time before drifting into our solar system, offering researchers a genuine physical sample of chemistry from a completely different stellar environment, something scientists almost never get direct access to. In January 2026, right after its closest solar approach, Japan's Subaru telescope added another layer to the mystery. By carefully analyzing the colors within the comet's coma, researchers calculated the ratio of carbon dioxide to water inside 3i Atlas. That ratio turned out to be significantly lower than earlier observations had suggested, hinting that the chemistry of this comet's coma was actively evolving as it moved closer to the Sun. In other words, this object wasn't behaving like some frozen, static rock. It was reacting, changing, revealing new layers of itself the closer it got to our star. Exactly the kind of behavior that keeps scientists coming back for more observations. But perhaps the strangest finding of all involved the comet's actual trajectory, and this is the part that has genuinely puzzled researchers the most. 3i Atlas is moving on what's called a retrograde path, meaning it travels in the opposite direction compared to how the planets in our solar system orbit the Sun. On its own, that's not unusual for an interstellar visitor passing through randomly. But researchers discovered something odd about the specific angle of that path. The comet's trajectory happened to align within just 5 degrees of the same plane that all the planets in our solar system orbit within. Something scientists calculated as having roughly a 0.2% probability of happening purely by random chance. To put that in perspective, the Milky Way's own galactic disk sits misaligned from our solar system's orbital plane by about 60 degrees. A truly random interstellar object passing through should, statistically speaking, be very unlikely to align this closely with our solar system's orbital plane by pure coincidence. That single detail has kept scientists genuinely curious, carefully working through every possible natural explanation before jumping to any dramatic conclusions. It's worth being clear here, because headlines about mysterious space objects tend to spiral quickly. The overwhelming consensus among astronomers studying 3i Atlas is that this is a natural object, a genuine comet, behaving in ways that are unusual but explainable through natural physical processes. Observations from a global array of telescopes and spacecraft have consistently found no signs of any artificial technology whatsoever. Researchers who have studied this object extensively have been careful to walk back speculation that strays too far from the actual evidence, emphasizing that unusual does not mean unnatural. That said, scientists have also been refreshingly honest about how many genuine open questions remain. Some researchers studying the object have compiled long lists of unusual characteristics, ranging from its unexpectedly large size and ancient origin to its surprising trajectory alignment and its complex, evolving chemistry. None of these details alone are shocking, but taken together, they paint the picture of an object that continues to defy simple, tidy explanations, even after more than half a year of intense observation from nearly every major telescope humanity has access to. One prominent researcher who has closely tracked these anomalies described 3i Atlas as only slightly less unusual overall than Oumuamua itself, largely because Oumuamua showed essentially no visible cometary activity at all, while 3i Atlas at least behaves like a genuine comet, complete with visible jets, an active coma, and detectable ice sublimation. That distinction matters scientifically because it gives researchers something concrete to actually study and model rather than trying to explain an object that broke almost every expectation simultaneously, the way Oumuamua did years earlier. Adding to the mystery, astronomers detected something called non-gravitational acceleration in the comet's motion, a small but measurable deviation from the path pure gravity alone would predict. This kind of behavior isn't unheard of in comets generally. It typically happens when jets of gas erupting from the surface act almost like tiny thrusters, subtly nudging the object's trajectory as ice sublimits unevenly across its surface. Researchers have identified what appears to be a genuinely complex system of these jets on 3I Atlas, which likely explains at least part of this unusual motion, even if not every detail has been fully worked out just yet. What makes tracking these jets particularly tricky is that they don't fire uniformly across the comet's surface. As different patches of ancient ice get exposed to sunlight at different angles throughout its rotation, they sublimate at different rates, creating an uneven, constantly shifting pattern of outgassing. Modeling that kind of behavior accurately requires painstaking work, comparing detailed brightness measurements, spectral readings, and precise trajectory calculations, gathered across dozens of separate observation sessions. It's slow, careful science, the kind that doesn't produce dramatic headlines overnight, but it's exactly the kind of work needed to eventually explain every strange detail this object has presented. By March 2026, 3I Atlas made its closest approach to Jupiter, passing at a distance of just over 53 million kilometers, remarkably close to the outer edge of Jupiter's gravitational sphere of influence. As of its most recent tracked position, the comet now sits roughly 1 billion kilometers away, well beyond Jupiter's orbit, continuing its long journey back out into interstellar space, never to return to our solar system again. And that's really the most humbling part of this entire story. This ancient traveler, potentially older than our own sun, spent countless years, possibly even longer, drifting silently through the emptiness between stars before briefly passing through our cosmic neighborhood. For a few remarkable months, humanity's best telescopes managed to catch a genuine glimpse of material from another stellar system entirely. And now, having delivered a wealth of unexpected data, unusual chemistry, and a handful of genuinely puzzling anomalies scientists are still working through, it's leaving, heading back out into the vast darkness between the stars, likely never to be seen by human eyes again. Researchers will continue analyzing the data collected from this brief encounter for years to come, slowly working through the mountain of observations gathered across its journey through our solar system. Every unusual detail, from its ancient chemistry to its improbable trajectory, offers a small but genuine piece of a much larger puzzle about how solar systems and the objects that drift between them actually form and evolve across the galaxy. Missions like this also quietly reshape how future observation campaigns get planned. Astronomers are already discussing how to better prepare for the next interstellar visitor, whenever it eventually arrives, learning valuable lessons from exactly the kind of blackout period that briefly cut off our view of 3I Atlas during its closest solar approach. Better coordination between ground telescopes and spacecraft scattered elsewhere in the solar system, ones capable of catching a target even when Earth's own view is blocked, could mean far fewer frustrating gaps in coverage the next time an object like this passes through. So the next time you look up at the night sky, remember that somewhere out there, a frozen visitor older than our own sun just passed silently through our neighborhood, briefly vanished behind our own star, and came back carrying secrets scientists are still working to fully understand. If stories like this fascinate you as much as they fascinate me, make sure you're subscribed, because our solar system keeps proving it still has plenty of surprises left. Thanks for watching, and I'll see you in the next one.